let me write down what we know so far. So far, here's what we know. We know that V final equals V initial plus A T. We know that X equals 1/2 X initial plus X V initial plus V final multiplied by T. And we know that X equals V initial T plus 1/2 A T. So we have managed to derive all these three equations. I need an equation now that does not have time in it. So that's what I want to do. So if I start I don't know where I'm going to start, but I'm going to start somewhere. X equals 1/2 V initial plus V final times T. So this equation has T in it, and I want to get rid of T. Can I do that? The answer is, of course. So in order to get rid of T, I'm going to write the following equation. V final equals V initial plus A times T. And then I would like to find an expression for T. In other words, I want T to be on one side, everything else to be on the other side. So I'm going to do that. If you take V initial to the left-hand side, it becomes, so V final minus V initial equals A times T. And if I want to find T, I'm going to divide both sides by A. And I will do that, and then T would be what? V final minus V initial divided by N. Right? Now I have an expression for T. If I go to this equation, anytime I see T, I'm going to put this instead of it. So that's the idea. I'm going to take this, and I'm going to substitute it in here. So if you don't unlike me, you don't have the luxury of having a board like that, what we could do is find a way of writing this more professionally by, okay, let's call that equation 1. Let's call this equation 2. And if I want to write this down, since you don't have the luxury of a whiteboard like I do, you're just going to say, I'm going to substitute equation 2 in equation 1, which means take this value, put it in that value. Or simply, arrows are much more. But I could write that even so somebody will follow it. And based on that, X would equal 1/2 V initial plus V final multiplied by T. But instead of T, what am I going to write? I'm going to write V initial minus V initial divided by A. Cool? Not cool?
Works.
Okay. What is A minus B times A plus B? That's right. Just to prove that he's not making stuff up, let's do it. A times A.
A squared.
A times B is
AB.
minus B times A
Negative AB.
minus B times B.
B squared.
And you will notice this and this cancels away. And look, he is right. He's not making stuff up. Cool? So if you guys look in here, I could write this also as B final final minus V initial. It doesn't matter, right? Because addition is commutative. So if you guys look at this, this is V final minus V initial, like A minus B times A plus B, which gives me what? A squared. So based on that, X equals 1 over 2A, and that would give me the following: A squared minus B squared. Good?
Yes.
So far so perfect. And now I'm going to multiply this side by 2A, this side by 2A. And that would give me the following: 2A x equals V final squared minus V initial squared. And then I could write this a little bit smoother if I wanted to, by saying that V final equals V initial squared plus 2A. Now, what I did not tell you, and I'm trying to not tell you, but just for the future, this is one way of deriving it, but I cheated. Because you can't divide by a vector. Right? A vector multiplication is different than regular multiplication. There should be something else. These vectors are multiplied. There are two ways to multiply vectors. We're not going to discuss this till chapter 9, so I'm not going to say anything about it. Okay? This is going to be called something called the dot product. You really don't care about it for now. We'll care about it later. Does that make sense? So when you write this equation, this is kind of complete. Kind of. But for now, we're trying just to say, yeah, things will work out at this thing. Cool? So here's are the 4 equations you need to memorize, write down on your cheat sheet something. You will be allowed